Today we are here to present a session on Reinvent Your Business with an AWS Modern Data Strategy. Let me start with, in these sessions, you are going to learn about Modern Data Strategy and how you can use AWS Data Analytics Services to implement a modern data architecture on AWS. We will also give you a demo of a real-time analytics use case, and we will talk about the couple of customer case studies during the session. So at the begin, let me call my business partner, Sanchit Jain, to start with Voice of Customer. Sanchit?
Thanks, Sudhir. So we do work with different partners across different industries. So whenever we start talking to them that, okay, how's your current architecture looks like? What's the current thing, how you are processing your business, how you are understanding that your data strategy. So commonly we always see the architecture is that there is a centralized warehouse in place where they get all of their traditional data from their structured databases. With help of ETL, they get it to the single schema, which is then they put it into the warehouse. This is a centralized information system around which the entire decision revolves. Increasingly, we see this architecture is getting out of fashion because of three reasons. Let's explore what are those three reasons. One, data no longer fits into the warehouse. We always think that data, whatever we have, will fit into the warehouse, but that's not true. If you really examine your system and storage, you will see there is an increase of 10x in your storage capacity every 5 years. And it's not just the structured data anymore. If we really talk about the data which is we are accumulating from different systems, it includes semi-structures. It also includes unstructured data. Semi-structures such as we talk about your entire social media feeds, application logs, or video feeds, right? So data is not going to fit into your traditional warehouse system. Second, there are many more people who really want to consume the data. It's not just the business folks who wants to run SQL queries and generate reports. There are data scientists, there are machine learning engineers, there are different lines of developers who really want to access the data and want to understand how the data looks like. And the accessibility medium is also not the same. Someone wants to run a machine learning algorithm. Someone really wants to do a real-time analytics, even a scientific analytics. So it's not going to work that, okay, one medium accessibility will work for all the personas. Third, and most important, as soon as we start opening the access of the data throughout the organization, there we see that we have to balance the democratizing of the data with the compliance needs. Some compliance needs, which are more industry-specific, like HIPAA, which is more in the healthcare, SOC 2, which is more used in insurance and all, or we talk about the regional compliances, the new ones, like GDPR, which is used in Europe, or we talk about the CCPA. So there, what we have realized after talking to all the different customers is, the customers are really looking for is a single framework or strategy where that strategy is cost-effective, allow them to store the data, allow different personas to consume the data in the form what they want to do. And that's where exactly we see a need of modern data strategy. Let me get Sudhir and talk about what exactly his exposure and experience has been with modern data strategy.
Thank you, Sanchit. Yes, you are right. Even we also hear the similar challenges and the modern data analytics requirement, and that is why the customers are looking for a strategy that can help breaking down the data silos by unifying and storing all your data at one place so that you can have a faster, better, and deeper insights from all your data. A modern data strategy gives you a coherent ecosystem where you can integrate or seamlessly access your data warehouse, data lake, purpose-built data services like the databases or even the machine learning in a manner that you can have the deeper insights with the minimal data movement. And also, as the Sanchit said, now the personas are changing. So the different personas require the different set of tools and services. And with the AWS modern data strategy, you will be able to do that. And on top of that, right, security, it always comes in the first. You always need a system where you have ability to protect and secure all your data. And with this modern data strategy will help you achieve that. Let's take a look of the core components of a modern data strategy. The first one is scalable data lakes, which is a foundational layer and the very key components of the modern data strategy. At AWS, customers use Amazon S3 to build a scalable data lake. The second is unified data access, security, and governance. The customer use AWS Lake Formation to unify the data by building a central data lake, and then they also maintain the access and permission right from one place. The third component is a purpose-built data services so that you get the best price performance at the lowest possible cost without compromising the features and functionality. And for this, we have a collection of AWS data services, such as Amazon EMR for big data processing. We have Amazon Redshift for data warehousing. We have Amazon QuickSight when it comes to the visualizations. So based on your purpose, you can choose a different set of service. And the fourth component is a serverless to give you the ease of use so that actually you will be able to get the benefit of all the cool features and the functionality we offer through the multiple data services, but you don't have to even touch or manage the infrastructure. The system scales up or down automatically. The fifth one is the built-in machine learning capability inside data and analytics services. And to give you some example, like for the Amazon QuickSight, we have ML capability so that you can actually detect the anomalies detection on the dashboard, live dashboards. And when it comes to, let's say, the predictive analytics on the data warehousing, we have a feature called Redshift ML, which is supported in the Amazon Redshift data warehouse. And in the next 30 minutes, we will be diving deep in all these components with more details. So let's start with the first component, scalable data lakes. As I said, the customers use Amazon S3 to build a data lake on AWS because Amazon S3 provides 99.99% availability, 11 nines reliability, unmatched maturity, scalability at lowest possible cost. Amazon S3 provides the multiple options so that you can bring your data in from the multiple sources, including the on-premises database or a file system, or you can also ingest the real-time streaming data coming from the IoT sensors and so many other places. And once the data arrive to one place, then actually you can have a platform where you decouple the storage with compute. Because you already have the data, now you can use the different purpose-built services like Amazon Athena or QuickSight or even Amazon SageMaker to run, access, and analyze all your data sets arrived in your Amazon S3. And the great thing with Amazon S3 is you can store any amount of the data in open file format, like JSON, CSV, Parquet. But it's not like just like storing the data. You will also be able to query that data from the multiple tools and services. Plus, it also offers the security capability so that you can, if you want to configure the security, yes, you can encrypt all your data which resides in your Amazon S3 data lake. The next thing is unified data access, security, and governance. So dumping all data in one place, let's say even the data lake, doesn't mean anything if you are not able to analyze the data sets. Because you need, first of all, you need to dump a data in such a way that it is queryable. And it's not about just a query capability. You also need to organize the data so that you get the best price performance when you start analyzing or querying the data. So earlier, the data engineers and solutions architects were spending several weeks or months to build a production secure data lake. But this is not the case anymore. Now we have a service called AWS Lake Formation that can help you build a production data lake in a matter of few days. And also you can enforce the security, governance, compliance right from a central, simple UI, so that you can achieve the tight security just from one place. And you can also define the auditing policies, so you actually know who is accessing what data. And you determine all the access, who are the people who should have access at the table level, column level, even the row level. Plus, you can also determine which services or tool should have access to your data sets. All these things you can easily achieve with AWS Lake Formation. The next component is the purpose-built data services to get the best price performance. So one size fits all for everything. This strategy is no longer working for most of our customers. AWS provides the broadest and deepest collection of AWS data and analytics services, so that you can use the right tool for the right job while building your application, especially to meet the unique requirement for your applications. And the requirement can be the scale, performance, or even the cost, or maybe the rich set of functionalities. In these sessions, I will talk about some of the services which falls under the analytics and the data lake category. So starting with the Amazon Redshift. So Amazon Redshift is a fast, fully managed, petabyte scale cloud data warehouse. And you can use Amazon Redshift to run the SLA-governed complex queries against structured and semi-structured data from your data warehouse. And it also offers the integrations with your data lake. It means that you can join your data warehouse data with the historical data, let's say the 20 years data which you have kept inside your data lake. You can join, plus you can also join this data with the multiple data sources, including the Aurora, PostgreSQL, or any RDS databases. So it means now the data warehousing is not limited to doing the batch processing and running for the BI use cases. Actually, you will be able to run the predictive analytics, streaming analytics, and even the self-service analytics right from your data warehouse, which is Amazon Redshift. And when you have the use case like the quick data explorations from your data lake, we have a service called Amazon Athena, which is a serverless. So you have an ability to query your data from Amazon S3 data lake, even without managing and maintaining any infrastructure. You can use the simple standard SQLs and query all your data which is stored in Amazon S3. Then we have Amazon EMR for the group of users who wants to take the advantage of open source framework such as Spark, Hive, Presto, Flink, even the Apache Hudi, and so on. So when you want to take the advantage of these frameworks, you can use Amazon EMR. And it's not like taking the advantage. We also offer some additional capability like the best price performance, along with all the capabilities you see with those open source frameworks. And when it comes to the log analytics, search analytics, we have a service called Amazon Open Search Service. And for the real-time streaming data, if you want to collect, store, and analyze, we have services like the Amazon Kinesis and Amazon MSK. For the data lake, I already talked about Amazon S3 and AWS Lake Formation. Now let's take a look of the next service, AWS Glue. So Glue is a service, the serverless service which provides the data integration. Okay, so you will be able to run the extract, transformations, and load from one data store to another data store. And it's also serverless, right? And the main thing it helps is stitching the different components together. As the name says, right, the glue, it means it stitches the thing together, and that is why the service name itself is a glue. You can use AWS Glue to do the multiple things. Like it offers the glue crawler so that you can automatically detect the metadata for your Amazon S3 data files. Not just S3 files, even you can connect to any data source, and you can catalog that metadata information in the central data catalog. And this central data catalog also you can create either in the AWS Lake Formation or the Glue data catalog. And it also offers the ability to create an ETLs without writing the complex codes. So normally when you want to write the ETL pipelines, you normally write the hundreds and thousands of the ETL code. With the AWS Glue Studio, you don't have to write all the codes from scratch. Basically, drag and drop features, it will help you to building your data pipeline, the ETL codes, with the simple clicks. Now, while talking to the customers, we also realize that they are looking for tools and services so that they can easily share their data, and they also want to onboard the data, third-party data in their systems without losing the agility and the security. And the good thing is we have AWS Data Exchange for that purpose. So with ADX, it provides you the interface so that as a publisher, you can create a public and private offers. You can define the terms and conditions to grant the access to your data sets. And this data will be available in the searchable ADX data catalog. So as a subscriber, you come, you search for a specific data sets, and you take the access to run your query. With ADX, actually, you can share your file in the form of Amazon S3 file, or even the tables which are cataloged in a Glue data catalog, or even the Redshift tables. And just to tell you that, with ADX, we have more than 3,000 data sets available, which is published by more than 250 providers. At AWS, innovation is a very constant, right? And you will see we are continuously improving our features and functionality, whether launching the new services and sometimes improving our services. So same way, we are continuously innovating our data services so that we can give out-of-the-box best query performance at the lower cost to our customer. And few examples, like with AWS Glue 3.0, now you can run your ETL jobs 2.5 times faster than Glue 2.0. And even the startup time is now less than a minute now. With Amazon S3, we introduced the intelligent tiering so that we can automatically offload your data to lowest cost storage tier automatically based on your access pattern. And that can help you saving the cost by up to 70% based on how we see the customers are using it. Then for Amazon EMR, with EMR 3.0, now 6.0, the customers are able to run the jobs 3.1 times faster than the Apache Spark at the 40% of the cost you pay for Apache Spark. And with Amazon OpenSearch service, you can store up to 9 times more storage. And with the introduction of ultra-warm storage, now you can reduce the cost by 90%. And with Amazon Redshift, now the customer can get up to 5 times better price performance compared to our competitor. Now I would like to call Veena to continue to the fourth component, the serverless for ease of use. Veena.
Thank you, Sudhir. So in this core component of modern data architecture, we are going to focus on the ability to build partial or fully serverless data lakes on AWS with the serverless offerings we provide. So we heard Sudhir talk about the benefits of purpose-built data services. And on the other hand, we also hear from our customers that they want all the benefits of these purpose-built data services, but they don't want to plan or manage infrastructure. Say they're looking for automated ways to do things like provisioning instances, OS patching, upgrades, disaster recovery, and so on. And for this reason, AWS has worked hard over the past few years to give a lot of serverless offerings to our customers. And this enables you as a user to focus on the core business logic, and you can let AWS handle the infrastructure for you. And there are other benefits to going serverless as well. For instance, it helps our customers to think big, start small, go faster into the market. And also it helps you achieve a high level of scalability. And you'll also end up spending less because you're only paying for what you're actually consuming. So these are all the serverless options we have for data analytics services in AWS. So they covered some of these services. Let me talk about 3 offerings we reintroduced in the last reInvent. For real-time streaming and analytics, we introduced Amazon MSK Serverless. For big data processing with open source frameworks like Spark and Hive, we built EMR Serverless. And for data warehousing use cases, we built Redshift Serverless. And all the 3 offerings I mentioned went generally available in this year. And also in this reInvent, we are introducing Amazon Open Source Serverless as well. And this just goes on to show the continuous efforts that we are putting into innovating in the serverless space. So on top of serverless, we also have several low-code and no-code environments, and this is to basically help our developers build their code easily. And this may include visual development, like the ability to drag and drop application components, or maybe developing code with fully managed notebooks. So these are all the environments we have to offer. Let me start with EMR Studio. EMR Studio is an integrated development environment used specifically by our data analysts and data scientists to build, debug, and monitor their big data applications. And they are able to build these applications using programming tools of their choice, like R, Python, PySpark, Scala, or even Presto SQL. And EMR Studio also offers fully managed Jupyter-based notebook interface to develop your code. Next, I'll talk about Glue Data Brew. Glue Data Brew is a visual data preparation tool, and it allows you to choose from over 250 built-in transformations to clean and sanitize your data. And this is without having to write a single line of code. And next, I'll talk about Glue Studio, which is a new graphical interface with which you can visually compose your Glue ETL workflows. And you can also create, run, and monitor these data transformation jobs. Next is Redshift Query Editor v2, and you can use Redshift Query Editor v2 to create, run your Redshift queries. You can visualize the results, and you can share them with your team members. The last leg of the modern data strategy will be built-in machine learning. And AWS offers a wide variety of tools and your AI and ML services to meet your business requirements, whether it be enhancing your customer experience or optimizing your business processes, or maybe if you want to improve productivity. And we have Amazon SageMaker, and Amazon SageMaker is a fully managed service, and you can use it to build and deploy your machine learning applications. And it also provides a lot of tools that you may need in every step of your machine learning development lifecycle, and you get it in one unified environment. So AWS also offers ML integrations with majority of its data services, and which enables you to use machine learning in your day-to-day analytics. And we are integrating SageMaker and other ML-related tools directly into the services that are being used by our database developers or data warehouse users or even business analysts. Let me talk about a couple of these integrations. So we have, from the data warehouse standpoint, Amazon Redshift is a service that is being used by many of our customers to query hexabytes of data on a daily basis. And on top of that, our customers have also expressed interest in ability to leverage machine learning on top of their Redshift data. And this is without having prior knowledge of machine learning. And that is the reason why we introduced Redshift ML, which is basically an integration between Redshift and SageMaker Autopilot. And this has helped our customers, our data warehouse users, to do some machine learning on top of their Redshift data and get more predictions out of the data. From the data analyst standpoint, we have Athena ML, and Athena is a service that is being used by our customers to query petabytes of data sitting on top of their S3 data lake. And they want to leverage machine learning functions on top of it, and Athena ML allows you to choose from over a dozen built-in machine learning functions on top of your S3 data, and easily with a query. And from business intelligence standpoint, we have QuickSight ML, which is again an integration between Amazon QuickSight Insights and SageMaker Autopilot. And this has enabled our business analysts to do things like forecasting or fraud detection or anomaly detection. And this is, again, without having to do any heavy lifting related to developing machine learning applications. And one more thing is we have customers like Expedia Group who are very appreciative of the QuickSight ML out of the box feature that they get. So now let's get into the fun part, which is the demo. And as Sudhir mentioned, we're going to see a fully serverless real-time modern data lake built on AWS. So I'll first give a briefing of the use case. We are going to collect, transform, analyze, and visualize the New York City public transportation data. And for those of you who are not from the United States or have never been to New York, I just want to set a little bit of context here. Metropolitan Transportation Authority, or MTA in short, is a public corporation who is responsible for transportation in the New York City metropolitan area in the United States. And they have these APIs. And these APIs are used to provide real-time information about the subway trains. And you can sign up to these developer resources to get access to these API endpoints. So these are the API endpoints. And as you can see, there is one API endpoint per set of train routes, which means for train routes, subway train routes A, C, and E, you have one endpoint. Similarly, for routes B, D, F, and M, you have another endpoint. And we'll be using those endpoints in our demo. So now let's review the architecture of the solution. And like I said, we have built the solution in a completely serverless fashion, which means that nowhere in this architecture I have to create, plan, or manage any infrastructure. It's fully serverless. So first, we have Kinesis producers that are running on top of AWS Lambda functions. And these Kinesis producers crawl data from the API endpoint that I showed you earlier, and is going to push the data to Kinesis data streams. I have one Lambda function per API endpoint, or in other words, per set of routes. For instance, for routes B, D, F, and M, it has its own Lambda function. And they send the data to Kinesis data streams. And this data is raw and unsanitized. We're just getting raw data from our API endpoints. So next step was obviously to transform this data to make it more fit for the downstream consumption. And for that purpose, we'll be using Spark Streaming application on EMR serverless. And this Spark Streaming application will just read the data from the Kinesis on a continuous basis, apply transformations, and store the results to S3. And this is happening on a continuous basis, so it's real time. And once the data is on S3, obviously you can do whatever you want with the data, like machine learning or business intelligence. For our use case, we'll be first performing exploratory analysis on top of this data using Redshift serverless. Athena is another serverless service that we will be using to run some interactive queries on top of this data. And finally, we'll use QuickSight to visualize this data. We'll maybe create some real-time dashboards. And we will also refresh the data to see any updates. So now I'll get into the demo. And before I start the demo, just one thing. So you can see the GitHub URL below. You can feel free to scan the QR code. And if you want to review the solution for later, you can do so. Or make a note of the URL, maybe after the session if you're interested to review our solution. And I have a pre-recorded demonstration, so I'm just going to play it and walk you through the demo. So let me start the demo with talking about the Kinesis data streams. I have two data streams here. I have the first data stream for trip status, which gathers information about the current status of the subway trains. And I have the second stream called trip update, which collects the information about the upcoming stops of a particular train. So I have two data streams that gather data from our AWS Lambda functions. So these are the AWS Lambda functions. I have 4 functions here for 4 different routes, and this runs the Kinesis producers. So I have the first Lambda function is for routes 1, 2, 3, 4, 5, 6, and I have the second Lambda function for routes J and Z. And let's go to one of them to check how it looks like. So let's go to the route BDFM. And if we check under the runtime setting, it uses Python 3.7 runtime. So we have written our Kinesis code in using a Python Bodo SDK. So this is the GitHub link, which contains all the information, like the dashboards we're going to show, the queries we're going to run, and even the Spark Streaming application code, the Kinesis producer code. So all of that you can find in this repo. So let me go to the Lambda function code first to walk you through the Kinesis producer. And I'll go to one of the routes. Let's do BDFM, for example. So this is the producer code. And here you can see the URL, the API endpoint that I was talking about earlier. And this is the endpoint for the routes B, D, F, and M specifically. And you can see the endpoint appended to the right. And this endpoint looks different for different train routes. And that is the reason why I have 4 different Lambda functions for 4 different route groups. And if I scroll a little bit down, I'm using the Kinesis client's push record API here to send this data to the 2 data streams that I showed you earlier, the trip update topic and the trip status stream. So all that we are doing here is we are crawling data from this MTA API endpoint, and we are just pushing it to Kinesis, no transformations whatsoever. And I'm going to invoke these 4 Lambda functions now with the command line interface. So I'm just going to copy these commands from the GitHub repo. And I'm going to switch to the terminal screen to run this in invocation. So I've run these commands, and you can see the processes have been initiated now. And these Lambda functions will now start producing data to our Kinesis data streams. Now, while I'm here, I'll also submit the Spark serverless streaming application. Here, I'm using the EMR serverless start job run API to submit a Spark streaming application. And what this Spark streaming application will do is that it will gather data from the Kinesis, will apply transformations on top of it in real time, and it will publish the data to the S3 bucket, which is the transform data files. And you'll be able to find the command that we are running here as well in the same GitHub repo. Now it's been a few seconds since we ran our Kinesis producer and also our Spark streaming job. So let's check the S3 path. So this is the S3 bucket. And you can see the last file that was written here at 2:44 UTC is the latest file written on the top. So I'm going to refresh. And you can see after 2:44, you can see like about 5 other files that got added. And these are the files that are coming from our Spark streaming application. So these are the transform data files. Now, once it's there, I can do whatever I want with it, like I said. And let's navigate to the Athena console here to run some interactive queries. So once I run the Spark streaming job for the first time, it's going to create this table for me in the Glue catalog. And I can use this table to run any interactive queries. So here, first, let's run a simple query to get the count of the train trips in my data set. As of the last time I ran, it's 186. So let's rerun it because we started a Spark streaming job, and let's see the update to this data set. So you can see now the number of trips is 208. It is increased. Now, another query I'm going to run is to get the number of minutes remaining until a particular train reaches the next stop. And here you can see for each row, for every train, you can see the minutes remaining until this particular train reaches the next stop. And there are other queries as well that you can find in the GitHub repo. In the interest of time, I'm not running all of them. So next is Redshift serverless. There's another way to perform exploratory analysis, and here I'm on the Redshift query editor v2. To run some exploratory analysis on this data, I've created a schema called Spectrum. So basically, we are using the Redshift Spectrum with Redshift serverless to query my Glue data catalog tables, which means I can query the same table that was created in EMR serverless directly without having to recreate the table. And with Redshift serverless, I can also run complex queries like ranking queries and use the power of Redshift to my advantage and get some high SLA guarantees and throughput. And this is the final stage of the demo, which is QuickSight visualization. So here I built visualizations by connecting to the Redshift table I showed you earlier. And I built a few charts. Let's go to the first one, which gives us the count of trips per route ID. And you can see the aggregated count in the middle, which is 182. And if I hover over each route, like A, C, E, you'll get the number of trips in that particular route. Now, this is 182, and there has been changes to our data. So let's go ahead and refresh our data set. Now, this is our QuickSight data set, which, like I said, is connected to the Redshift table. And you can see that we have already scheduled an hourly refresh starting at 2:08. And you can see exactly at 2:08, there is a refresh that took place. And there are other manual refreshes I did as well. So now I don't want to wait until the next hour. So I'm going to go ahead and just do a manual refresh now. And it's going to take about a second or so for this refresh to happen. Now the status is in progress, and it's going to complete in a second. It's completed, and you see that 211 rows got imported. Now, if I go back to that tab, you'll be able to see the increase in the number of records. So you can see that after the refresh, our records increased from 182 to 211. And now we can see the same thing being reflected here in the QuickSight dashboard. I'm going to refresh the page, And you can see that the aggregated number of trips went from 182 to 211. And this is the last part of the demo I wanted to show. And this is to highlight the benefit of serverless architecture. If you see, what I've done here is this is a CloudWatch dashboard, and I've taken one metric from each of the servers that we are using to show the scalability factor. So here, for instance, on the far right or left, there is EMR serverless, which has the capacity allocated metric in the dimension of CPU memory and storage. And you can see the resources scaling up and down dynamically based on my Spark streaming job requirements. And you only spend for the resources you actually use, and that is the advantage of going serverless. Same is the case with Redshift serverless. With Redshift serverless, I've taken capacity, compute capacity, and it changes dynamically based on the compute used by your Redshift queries, and you only pay for, again, what you actually use. And you can find this dashboard as well in the repo if you're interested to sort of see that. And that brings us to the end of our demo, and hope it shows how serverless architectures help you scale and also spend less. So the next part is the case studies and reference architectures. And many of our customers leverage modern data architectures on AWS to drive better business outcomes. So I'm going to call upon Quantify Partners, Sanchit, who has implemented some of these architectures for our customers. Thank you.
Thank you, Veena. So I think we saw in today's keynote also given by Swami, right, how important it is for the companies or for the customer to adopt modern data strategy. Similarly, as a customer, as a partner, we have implemented modern data strategy for multiples of our customers across different industries. Let me take 2 examples and help you explain what exactly or how the business has benefited with adoption of the modern data strategies with them. So the first case study is the connected vehicle platform. This platform was developed for one of the largest fleet management company, which has a presence across 30 countries and holds 1.7 million of vehicles. The challenges what faced by are they were not able to acquire the data real-time fashion, and because of lack of that capability, they were not able to explore their data, not able to understand how they can improve the safety of their drivers on the road, not able to understand how their drivers are driving the car on the road, as well as how they can better utilize their assets. So those were the different pain points which were with the customer. We enabled a solution with help of modern data strategy on AWS and different AWS serverless and analytics services like Lambda, Athena, Glue. We leverage all those services to solve this problem and help them to figure out different KPIs, such as at what speed the driver is driving on the road. Is it overspeeding? Or is the driver is idling on the road for half an hour with machine is on? Or what's the average consumption of the fuel on a daily basis? Yes, this all questions are very important when you talk about any customer in the fleet industries. So that's what we build the entire platform by acquiring the data real-time fashion and help them to solve this problem. And with this platform, they saw the advantage is from a technical perspective, they not only see a cost reduction with the serverless services, they also see a reduction in their entire deployment cycle, and we're also able to get better asset management. Let me talk to you about in detail how exactly the architecture used to work, right? So this is how the framework or the different components were, how the components around it. Let me start walking you each pillar by pillar how we and what services we use in what fashion. First, on the left side, we acquire the data from different fleets, such as vehicles, with the help of IoT data. And the data was acquired with services such as Lambda, API gateway, and within this Lambda, there was code written to acquire the data and put that data into the storage. The data was stored in a raw format on S3, which helps them to even do machine learning and other kinds of stuff in future. But from this project perspective, we leverage Kinesis Firehose as well as Glue. These both services able to enrich the data. So I think my colleague just mentioned about data exchange, where there are public data sources available. So OpenStreet is another data source which is available by Athena. So we enrich the data which was acquired by the fleet. We merge that, enrich it with open source, and store it into the transform format in a Parquet format in S3. And similar data was also stored in Redshift, on which the data marts were created. Finally, this entire data was used and consumed in real analytics form, as well as in summarizing. So things such as, is my driver is speeding more than 65 miles per hour? Such kinds of real-time KPIs you can track with the real-time capability of the platform, and it automatically sends an SNS to the fleet manager that your driver is overspeeding. But if I want to consume, or if I want to identify what is the average mile my driver has driven throughout the day, or what's the fuel consumption in a day, those kinds of KPIs was done with help of the summary generation, which was done on daily, weekly, and monthly basis. This entire data was been stored into the Redshift, and finally, with the help of QuickSight and API, this data was monetized to the end customer to understand how their drivers are driving and what the behavior looks like. Not only that, we help the customer to adopt DevOps maturity by leveraging CloudFormation and Jenkins, and automated this entire platform, which helps them to deploy this platform, and as well as simple to manage this platform. So this is one of the case study what we have done. Let me talk about the second case study, which is for the manufacturing industry. So this smart manufacturing platform was developed for one of the largest global manufacturing machinery supply for 2K machineries. The big problem for manufacturing industry, if I talk about, is how better you can understand your inventory. That's the key thing. And that was the same problem for this customer. They have presence across the globe. They have different presence, different factories in Europe, Asia, even in North America. How they can consolidate this data across different factories and perform data processing in a near real-time fashion, rather than doing it on a need basis. So with help of the modern data strategy and different services like Redshift, Glue, or we talk about Athena, we help them to build the entire automated pipeline, which help them to acquire the data in a near real-time fashion and solve the problem what they're looking in terms of better inventory management, as well as monetize their dashboard by doing embedded analytics with help of QuickSight. And with the adoption of the platform, we saw there was an 80% business efficiency for the customer. Not only that, customer was better able to understand how the factories have been performing across the globe. And with that help, they were also able to make better understanding of the utilization of their inventories. Let me talk about how the architecture used to look like. So these were the three major pillars what we had. One is the entire data ingestion or ingestion pipeline. The second is the core, my lakehouse, which is the combination of my data warehouse and the data lake. And at the last, we had the entire consumption. We acquired the data. There were two sets of data sets we acquired. One is the entire machinery data with help of PLCs and Kinesis, which we acquired. The second is the configuration data, the one-time configuration data, which was uploaded to S3. Then there were a couple of Lambda functions which was used. These Lambda functions were used more to ensure that the data have been stored properly, it has been refreshed, or the glue jobs have been invoked. So we can not only acquire the data, but even we can process the data and make it available in a near real-time fashion. And all the logs from this Lambda function were stored into DynamoDB from a log monitoring perspective to see it and ensure if something is failure, how they can track it and how they can rerun that. This entire data, with help of Glue, was stored into the S3 in a raw format, as well as it was being stored, processed, and stored in a Parquet format in S3, as well as it was stored into Redshift, into the states table. And finally, on the Redshift warehouse, we did data marts from the staging layer, which helps them to address the different kinds of business scenarios or business problem what they're looking for. The entire consumption was done with help of the reports, which was generated on need basis with SQL, as well as we have plugged the QuickSight. Similarly, we saw in the demo given by Veena, the QuickSight was plugged on Redshift data marts, which allowed them to understand how the factories have been performing across the globe in a near real-time fashion rather than doing on periodic basis. From an excellence perspective, we also took all the logs which was generated throughout the platform and put it into OpenSearch. We also saw the OpenSearch serverless which got announced today. We use OpenSearch and put an OpenSearch dashboard on top of it for in terms of generating the dashboards and other all. So you don't have to really go into the console and understand where is my Glue, where is my CloudWatch, where is my Redshift. Within the one centralized dashboard, you can understand what's happening and how my platform is performing. And at the last, we package this entire platform with help of the entire best practices by adapting to DevOps and security. So things such as we talk about cloud formation, which is infrastructure as a code. We talk about code commit, which is a code repository, code build, or code pipeline, which is used for CI/CD. And at the last, we also use a couple of security services like KMS, Secret Manager, in terms of ensuring that the entire platform is secured and robust. So this is the architecture what we have developed for this manufacturing customer, which helped them to accelerate their journey on the cloud as well as get business efficiency. But when we work with our customers across industry, there is one more voice which we hear is, what is data mesh? We also have a need to make our data lake design to more complex. Can you help us to understand data mesh architecture? So let me invite Sudhir to talk about what is exactly the data mesh and what he thinks from the market standpoint about data mesh. Sudhir.
Thank you, Sanjay. Yeah, a data mesh pattern is another trending topic nowadays. If you are not aware of, AWS data mesh pattern is a decentralized architecture and operating model which is based upon the 4 key principles. Domain ownership, data as a product rather than assets, a self-service data platform, and the federated governance and compliance. And these patterns makes more sense for a large enterprise where they have the large complex landscape separated by the different line of business or the business units. And the good thing is you can achieve this pattern with the help of AWS modern data strategy. So now let me explain how can you extend the AWS modern data strategy to even build a data mesh pattern. So first of all, you create a data mesh account where you have a central data catalog and the service data catalog. You keep your CloudFormation's libraries, and you also keep the federated access and compliance policies so that you can control who have access to which data product to the different producer and the consumers. And then each line of business units, in this case, they are called a data domain. So they also create their own data lake based on architecture. So basically, they catalog all their data in the searchable data catalog. And then they use the different purpose-built services to run their applications. And to provision all these services and the different configurations, they use the same CloudFormation libraries which is available in the central data mesh account. So basically, you can think the the data mesh pattern as a collection of data domains, okay, where the different producer owns one or more data products, and basically they publish their data sets into the searchable data catalog, which is available in the data mesh account. They also define the federated access, compliance, governance policies to define who should have access to their data product. And as a consumer side, you go and search their data from from the central data catalog, and then you gain the access to that data product to run the analytics. Just to add one more thing, the similar patterns is used by one of our customer, JP Morgan Chase and corporations, to run the modern data analytics on AWS. Sometimes customers feel that because data mesh pattern is really trending, they need to implement it for every single customer. This is not also the right. There are several customers who are creating a centralized, unified data lake for the data consolidations and even the data consumptions. So use the data mesh pattern only when you have a case of the different business units operating in the different manner, but they still want to exchange some of the data from one place to another place. AWS modern data strategy, we classify into the 3 stages. The first is the modernize, where you modernize your data platform by moving it to the AWS or any cloud provider, basically, so that you have the trusted, scalable cloud to run your infrastructure. The second is the unify, where you break down the data silos by unifying all your data at one place. And the third stage is innovate. So basically, you use the analytics and machine learning capabilities to invent the new experience for your customers. And all these 3 stages, it's not sequential. You can run all 3 stages in parallel depending on where you are in the modern data strategy, in the journey. So by now, you may have some fair idea about what is all about the AWS modern data strategy. Now let me talk about some of the resources and the programs available for you that can help you to implement such strategy and the platform for your customer. So we, data analytics partner team, we have created the bunch of the self-service material and the self-service trainings recordings, which is available in the AWS Partners Central Portal and AWS Skills Builder that you can use to gain the expertise on the different services and the use cases. We also run series of trainings and workshops focused on individual services as well as on the use cases. Let's say the data warehouse migration, that is a use case, and we run those training and some workshops, especially designed for our partners and customers to understand those use cases very well and implement the modern data architecture in easily. And then we also offer we have the strategic AWS partner program, such as AWS Service Delivery Program, AWS Data Analytics Competencies, and very prescriptive use case-oriented Analytics SI Acceleration Program. If you are not aware of any of these programs and the trainings, I highly recommend reach out to the Alliance team or the account manager. And if you are working with partner development manager or partner solutions architect, have a word and understand what are the benefits and these programs and sign up for that. And once you are enrolled to these programs, you get several benefits like listing on the web page, funding support, go-to-market support, even the access to the exclusive content, including the roadmap, positionings, and so on. And just to summarize, let's use the different materials and the trainings available to learn the different use cases and analytics services, sign up for the AWS programs, and help differentiate yourself from others, and then talk to your customer, identify where they are in the data modernizations process, and help them modernize their data so that they understand the value of AWS for the data. And with this, we reach to the last slide. Thank you so much.